Now, it shouldn't surprise me after all this time, but I still do get flabbergasted at the time when we get to the senior courses, how badly we add and subtract fractions. And especially once we start to add algebra in there, it really gets bad. I think sometimes our calculator skills lead us away from being able to add and subtract fractions. But unfortunately, you can't get away with just a calculator when we're doing algebra and we have fractions there. So we've got to remember our rules. So it's this first one, adding and subtracting fractions. Remember, we need a common denominator. Now, I say common denominator. What I really want is the lowest common denominator. And that's a problem too for some students because, unfortunately, they've been taught badly. Whether in primary school or secondary, wherever, they get to a point where the teacher might say, well, just get a common denominator. It makes life really difficult with fractions and algebra because we really don't want a common denominator. We want the lowest common denominator because we don't want to be adding extra lines of our working to try and cancel things out. So hopefully we'll see as we go through what I mean. So the first one, 5x over 2, x on 3. Well, our lowest common denominator, 2 lots of 3, gives us a 6. That doesn't go into anything lower. So we've got to change our 5x on 2 to be a fraction over 6. So that's why if the 2 is being multiplied by 3, the 5 will be multiplied by 3 as well. Because what we want to do is basically get an equivalent fraction. This is what it's all about. Changing it so it's an equivalent. It's the same fraction, just written in a different way. So 5x on 2 can be written as 15x on 6 because 5 goes into 15, 3 goes into 15 5 times and 3 goes into 6 twice. So there's your 5 on 2. So it's the same fraction written in a different way, but we need it to be in terms of 6, not in terms of halves, because halves are too hard to work with when we're working with thirds as well. We need them all broken into nice parts, which are sixths. And x on 3 becomes 2x on 6. I multiplied 3 by 2, multiply x by 2. Then I can, because they're all in terms of 6, I can say, well, I've got 15 sixths of x minus 2 sixths of x, which is going to leave me 13 sixths of x left there. So that's how we're going to do that one. What if there's just all algebraic terms in the denominator? Well, again, the lowest common denominator would be x times y times z when they're just the multiplying of the 3. There's no lower denominator. So to get 1 on x to be looking like that, we need a situation where we get the x times yz, but then the yz times on top. So if we had z times y multiplying on top to get the y and the z, so z and y is multiplying by the x, so they multiplied by the 1, and if they cancelled, that leaves us the 1 on x still, which we go back to. But then y is going to be multiplied by x and z to get x, y, z in the denominator. And 1 on z is going to be multiplied by x and y to get the same denominator. And we get that on top. Our numerator becomes that. Notice we can't simplify it at all because there's no common factors and there's nothing, and there probably shouldn't be in this case to get that. If there is, then we've done a little bit something, probably done something wrong because it shouldn't be able to cancel down like that. Again, 1 on x, y, and 1 on y, z. Now this is where students get themselves into trouble because someone would just go, okay, x, y times y, z, and that's going to give me x, y squared, z. That's not our lowest common denominator because what would be the lowest number that x, y would go into that includes a z? Well, xy times z would give us that denominator there, and yz times x would give us that denominator there. So it's not our lowest common denominator. It's a bit like having a situation where we've got a half plus a quarter. And you go, well, that would just give me, if I do something in eighths, I don't really want to go to 4 on 8 and plus 2 on 8, because then I get my answer and then it's not in its lowest terms. I'd rather go, well, a half can be written as 2 quarters. I've already got a quarter there, so that gives me 3 quarters. Now I can get down that one and say, well, that one's 3 quarters, but then I had to do an extra step. I've had to do extra working to get there, and that's the same thing here. If I got just multiplied both of them, this one by yz and this one by xy, and get a yz on top and an xy there, I'd end up with y's here, and then I have to cancel a y and a y with the y squared, and I'd still end up with that. But by getting my lowest common denominator, I've saved myself work, and that's the key. Question 4, again, our lowest common denominator, 2 times 3, and we treat this as x over 1. So, well, whatever we get as our lowest common denominator there, that's going to have to be the same number. So 2 times 3 gives us the 6, that's the lowest. So we multiply 2 by 3, so the x gets multiplied by 3. Our 3 here gets multiplied by 2, so the 2x gets multiplied by 2 to give us 4x. And our 1 gets multiplied by 6 to give us x over 1 in terms of 6. So it would be 6 lots of x on 6. And the 6's would cancel when we get back to that one. We do our subtraction and addition there. That gives us minus 1 plus 6 gives us 5x over 6. So there's that one there. So we're hopefully seeing the idea that we can start to get our lowest common denominator, and it starts to make life a little bit easier. So again, this one here, 5 on D, 3 on D. Well, again, and 1 on 1. So it's really not too hard to do that one. But 2D would be the lowest. We're multiplying D times 2D and get 2D squared. That's going to make us get more D's up here that we need. So we just multiplied this one by 2, because that will give us 2D as a denominator, and 10 there. 3 on 2D we don't have to touch. It's already in its lowest form. And 1 on 1 becomes 2D on 2D. So you can see, technically we've got 3 separate fractions here, and then we're just adding them up. Even though that looks like 1, there's 3 separate fractions because of the addition and the subtraction there. So we have that 13 minus 2D on 2D. Doesn't simplify any further than that. 3 and 2 here, well, we like the 6, so that's as lowest it's going to go. So the x plus 1 gets multiplied by 3, the x minus 1 gets multiplied by the 2. And that's going to be our lowest, and then we can expand out, we get our lowest terms there. 3x plus the 2x is 5, 3 minus 2 gives us the 1. So that's where all that comes from. So the next question here, what we've got to do is be careful with these ones. Now, we've got 5 and 2, which gives us 10. So to get a denominator of 10, we multiply the x minus 2 by 10. Then we multiply the x plus 3 by minus 5. Now, we have what we call an implicit bracket here. Now, when I multiply the 5 there, I'm technically multiplying by minus 5. So that's when the minus 5x and the minus 15 are going to come into play. Now, be really careful. A lot of times we see the minus 5x get picked up, but then we forget about the minus 5 has to multiply by the 3 and we get a plus 15. And it's going to throw our fraction out. So be really careful. Even though you're looking here going, well, there's no bracket there, we call what we've got there is an implicit bracket. Technically it's minus all that. And then remember, that's 2 different fractions, but it's minus all that fraction. So by design, it's written that way, but because we don't need to put the bracket in, we don't do it. But it's implied. It's not explicit. You don't see it, but there's an implication that there's a bracket around those two terms there, and it's the whole thing, not minus the whole thing there. The same thing happens with the next question. A minus x plus y over 4. Technically, there's a bracket around the whole thing. It's not. It's an implied bracket, and that's why I like putting it in, and not just trying to skip from this step to this step. And that's where we can go and get into problems. Try not to miss steps with these ones. I try not to, because again, problems can occur and errors can occur way too easily if I go too fast and I'm not taking care of all the minor details of this one. So in this one, 3 times 2 times 4 gives me 24, but that's not the lowest common multiple of 3, 2, and 4. That actually is 12. So again, be really careful. 5 and 2, lowest common multiple is 10. 3 times 2 and times 4, the lowest common multiple is 12, because 2 technically goes into 4. So 3 goes into 12 4 times, so we'd multiply 3 by 4, and the numerator by 4. 2 gets multiplied by 6 to give us 12, so 3 gets multiplied by 6. And then 4 gets multiplied by 3, so x plus y gets multiplied by 3 with the negative there. So notice we're going to get the minus 3x minus 3y to simplify, and then once I've got there, I can collect my terms all over 12. So be really careful of what we call the implicit bracket, and again, I've got it there, so I haven't put the implicit brackets in there. I'd probably recommend you do that all the time, even though it's minus 1 there, but it's a minus 1 times 1 and a minus 1 times 3 as we go through there. And that's a common denominator of 3, even though it's x over 1, The common denominator would be 3, and we got the 3x over 3, then get it together. This one, lowest common denominator we're going to get is not just the multiplication of the 2, x minus 2, x minus 1. So the 3 gets multiplied by the x minus 1, because you can see they'd cancel it to get back to that one. 5 over x minus 1, we multiply both by x minus 2. Notice our denominators start to be the same, but if we cancel them, we'd go back to what we had. But that's not our aim, because we want to collect our terms. So, but really take note of that. You could go back that step really easily. Again, implicit brackets, minus 5 times x, minus times minus 2 gives us a positive 10. So be really careful there. Collect your terms, and hopefully we don't make those errors and we can collect our terms and get it correct. And then we have a look at this one where it's a on a minus 1 and a plus 1 on a. Well, again, lowest common multiple would be just the multiplication of the two of them. So the numerator and denominator get multiplied by a there, so that's where we get the a squared. And this one gets a minus 1 times the a on top and bottom. Notice we get the difference of 2 squares there. And then, again, because it's the minus there, I've kept the minus there. That was the difference of 2 squares. But then we can expand our bracket and get a minus a squared, which cancels. And the minus times minus 1 gives us positive 1. Again, careful of the signs. Now this one here is one where I've actually gone about it the wrong, probably not the right way, because I haven't got the lowest common denominator here. Bad on my part, because when we look at that, that's not the that isn't the lowest common denominator there. We could take an x out there of both of those. So when I get down to this part, I haven't got the lowest common denominator there. What I can write there is I get a 2x over, and I can take an x out there and get x minus 1 and x squared plus 1, and my x's can cancel there. Sorry, I've got the x squared plus x, but then I could technically get another x out there and have 2 outside of x minus 1, and then x plus 1. I probably should have gone and written it that way, which made life a lot easier. See how I'm taking more effort to get to the most simplified answer that I could write. I could leave it like that or like that. That's not too big a deal going from either one of those. But I had to do extra steps. So there's a case where I probably should have looked at this one as x outside of x minus 1, and this one be written as x outside of x plus 1. So it already had a common factor of x in both of them when we had that. So, and then get a common denominator, I'm only multiplying by x minus 1 here and x plus 1 there to get my lowest common denominator, and it would have worked out much neater. So there's one to learn from the errors there, and it's a good example of what not to do and how it makes life easier and makes life more difficult if we don't get that lowest common denominator. So keep those in mind. Keep your algebra rules in mind. And as I said, the last one is pretty difficult. So is 11. So we've got to be really careful with all those signs as implicit brackets and getting that lowest common denominator.